Well, I hope you had a good weekend, and I hope you have that memorized. Okay?
Yep.
Good. I believe I've got one of these uploaded on the website. If you want to know, if you want a nice, clean copy, you're welcome to print one of these off. Here's the way it looks. It's got the whole unit circle. It's got the angles and radians and degrees all nicely printed on there. Each one of the coordinates for the x and y values on the unit circle printed on there. It's also got the tangent of each one of these in the first quadrant marked down there and figured out for you. So the tangent of 0 is 0. Tangent of pi fourths or tangent of 45 is 1. So if you want that, that might be a good thing to have just as a reference. Don't rely on this like some people get counting on their fingers in elementary school and then they can never get away from that. You really need to know this just inside out and backwards. If you want a clean copy, you know where to find it. But I wouldn't have one where you're sitting doing your assignment and there's a page like this right next to you. That's not a good idea. It's a good idea to have a nice clean copy to memorize from, but then put it away when you're doing your homework because you're not going to have that on a test. You better get used to that. Yeah. Sure, I think there's blank copies on there also. One's called Quiz Yourself, and the other one's called Quiz Yourself Answers, or something like that. Okay, all right, and it's under the unit circle page. Okay, it's right by chapter 1. Anything else? Okay, it's going to be very clear whether or not you understand the unit circle and have that memorized. That's going to go very quickly. Okay, we're going to have to work this out. Can you see okay, or am I in your way all the time? You sure? You want me to get shorter? Okay.
We're
All
going
right.
to cut off the enemies.
Okay, I'll do this. Okay, please make sure you have that because we're going to use that a bunch today. So here are the notes for 6.5. It's on something called right triangle trigonometry, which is what we do for most of the course. Okay, this is the stuff where if you know the things in chapter 1, you can figure out nearly everything in this textbook out. So, before you get too excited, you have a front and a back side. I have one more problem that we're going to do at the end. You'll need a piece of scratch paper in order to do this. Okay? All right. So, starter question at the top. It says, what is the cosine of pi 6? What is the sine of 60 degrees? And what is the tangent of 45? You should be able to figure that out really quickly. Go ahead and do that. It's been a long weekend, been 5 days since I saw you. And can everybody still see okay? Good? Tell me to move forward. I might have to move the chairs. Okay, so if you're doing a problem like this, this is what you'd think. I wouldn't necessarily write this just because it takes time. You could draw a picture for this. We'd have to think pi 6, that's the same as 30 degrees, so it looks like this. We've got 1, a 1/2, and a radical 3 over 2. That means the coordinates on the unit circle are radical 3 over 2, comma 1/2. And I know that on the unit circle, the cosine is which coordinate? The x coordinate. So this is radical 3 over 2. Now, if you can picture this and just know, gosh, I need the x coordinate on a 30-degree angle on the unit circle, and just know that it's radical 3 over 2, it should get to the point where we say, hey, what's the cosine of 30 degrees? And within about a second, you say, oh, that's radical 3 over 2. Okay, sine of 60 degrees. It's also radical 3 over 2. You could take the time to draw a picture that looks like this. That would be 1, that would be radical 3 over 2, and that would be 1/2. Okay, write down the coordinates and all that sort of stuff, but much better if you just have it memorized. So there's our answer on that one. And then the tangent of pi fourths. Tangent of pi fourths is 1. And again, the reason for that is that would be a 45, 45, 90. These two are the same. I don't even need to write down what they are. I know this is the y coordinate and this is the x coordinate, or the opposite and the adjacent. If they're the same number over same number is going to produce a 1. So there's the tangent of pi fourths. Any questions there? Okay, then let's take a look at the next line. So what we've been doing so far, is we've been taking an angle and then figuring out whatever the corresponding ratio is, whatever we've been told to do. So to emphasize that point, and this is important because we're going to be doing the opposite of this in just a second, trig functions take angles, and what do they give us in return? They give us ratios in return, okay? So we're going to plug in an angle, and it's going to spit out whatever the corresponding ratio is, okay? Like most processes in math, like most operations, we can undo this. We can do the exact opposite of this. So I'm going to ask what looks kind of like a weird question. Maybe it is, maybe it isn't. Okay, find an angle whose cosine is 1/2. Find an angle whose cosine ratio is 1/2. Okay, in other words, that's saying find an angle, or an alpha, that makes that equation true. So what angle would we plug in here to make that equation true? What would it be? 60 sounds pretty good. If it said answer this in radians, we'd have to say pi thirds. We've got to be that quick at recalling those sorts of things. Okay? So this is the exact opposite of what we've been doing. Instead of being given an angle and it spits out a ratio, we're telling it what the ratio is, and we want to find out what angle that corresponds to. So in order to solve this problem, here's what we're going to do. We're going to draw an acute angle in standard position, and then we're going to label the sides. So we're going to draw an angle like this. Okay, always drop this straight down to the x-axis. Make that look a little bit better. And then we can actually solve this in one of two ways. The first way, which is the one that I would recommend, because if you've studied the unit circle and got that all memorized, this is going to be the easiest. The first way is to think, well, the cosine of an angle is the x-coordinate on the unit circle. So I need to make a triangle on the unit circle where the x-coordinate is the ratio that I'm interested in. So this is going to be 1/2. It's on the unit circle, so we know the radius has to be 1, the hypotenuse has to be 1. And then I can stare at that for a while. If I need to mentally fill in that this would be radical 3/2, or worst case, and I hope nobody has to do this, but you could use the Pythagorean Theorem to find out what this one is. But we should recognize that if this is 1/2 and that's 1, this has got to be a 30, 60, 90. Because remember, the short leg is exactly half of the hypotenuse. So that means this is the short leg, that's the small angle, that's 30 degrees, and this is 60 degrees. So there's our angle right there. So our answer on this one is 60 degrees, or we'd say pi thirds. Okay? That's one way to think of it. Okay? And again, I think that's the best way because it reemphasizes what we learned about the unit circle. All that stuff that we memorized and studied there, we're just using it going in the opposite order. The other way to solve this problem, which can be very useful, is to think of this in terms of the two sides that are used in the cosine ratio. So we're going to draw a triangle again, and we're going to think of this as the names of those two sides, or if you wanted to think of it in terms of x's, y's, and r's, that would be okay. Either way is all right. Okay, I'm going to think of this as the adjacent, and this is going to be the hypotenuse. So the adjacent side is 1, the hypotenuse is 2. Now we could stare at that for just a second. Hopefully you know what that one is. You could just recognize it. Again, it's the same relationship. If you have a leg that's exactly half the size of the hypotenuse, this has to be a 30, 60, 90. This has got to be the long leg, so this would times by radical 3. That means this is a 30-degree angle and this is a 60-degree angle. It's the exact same process, we're just thinking about it in a slightly different way. And again, both of these techniques are important. They're both useful. I would know them both. When it's an easy problem like this, you're definitely going to be using this one right here. If it's something you might struggle with a tad more, you're probably going to want to draw a picture and then just label the two sides. Okay. Any questions? Can somebody tell me the difference between these two triangles? Yeah, this one is twice as big as that one. Other than that, they're similar triangles. The angles all measure the same. It's just that this one's twice as big, or thinking the other way, this one's half the size of the other one. Any questions? Okay, so the problem that we run into is because we often use trig functions, we give them angles and they spit out ratios, and we often do the opposite quite a bit. it would be good if we could come up with some sort of symbols that would represent what we're doing here, okay? Because we do this so often, we're going to use some terminology. So if you think about what we were doing the opposite, or the word that we use for that is the inverse of the previous operation. So an example of an inverse would be if f of x is x squared, then f inverse, and that's the notation. Again, whenever you put a -1 above a function, it doesn't mean reciprocal. Okay, it's not an exponent. It just literally means the inverse of that function. The inverse of squaring is the square root function. Okay, and you studied inverses a lot in both 1010 and in 1050. Okay, don't forget that on a lot of functions you've got to restrict the domain so that its inverse is a one-to-one function. So remember on parabola, you can't just take this and reflect it across the line y equals x. You can't just find its inverse without restricting the domain, because what's wrong with this blue graph? It's not a function, okay? So what we'll often do is we'll take this and we'll restrict the domain. We'll say, let's just use the parabola on this side, and then the top half of the parabola on this side, okay? Then they're both functions. They're both one-to-one functions. There's that one-to-one correspondence that we're interested in. Okay, any questions there? Okay, so let's talk about the inverse trig functions. So this is sine inverse, cosine inverse, and tangent inverse. Okay, that's what that little -1 indicates there. That means, well, let's see for just a second. If this right here is an angle, what is this right here? It's got to be a ratio, okay? So let's fill in this line right here. So here's a box that I copied out of your book. It describes what those inverse trig functions are. Okay? Inverse trig functions do the exact opposite of what regular trig functions do. So please don't forget this. This is why we talked about this earlier. Okay? Regular trig functions take angles and give ratios. Inverse trig functions do the exact opposite. They take ratios and then they give in return angles. Now, for the time being, you're going to need to take this stuff for granted, okay? So if we give sine inverse a ratio, it's going to spit out an angle, and that angle is always going to be between -90 and 90. It's going to be in this part of the unit circle, okay? So this is what we're going to use for sine inverse. All the triangles that we draw are going to be in quadrant 1 and quadrant 4. If we're using cosine inverse, it's going to give us answers between 0 and 180, quadrant 1 and quadrant 2. So that's for cosine inverse. And if we're doing tangent inverse, whenever it gives us an angle back, it's going to give us an angle between -90 and 90, or again in quadrant 1 and quadrant 4. Now, for the time being, if you just keep these in mind, if it's sine inverse, it's quadrants 1 and 4. And if it's cosine inverse, it's quadrants 1 and 2. Now, I'm not going to spend a lot of time talking about why this works the way it does. We're going to do that in a later chapter, in a later section. But can somebody give us a ballpark idea? I know some of you have had Trig already. You've taken pre-calculus. Can somebody give us an idea of why we have to just restrict ourselves to certain quadrants? It has to do with that one-to-one idea. It has to do with restricting the domain. Okay? And that's all we need to say for right now. If you want to come up and talk to me afterward about exactly why it works the way it does, I'd be happy to go into a more in-depth explanation that we'll go into with everybody later on, but that's basically it. Okay, it's a domain restriction that makes things work out the way they need to. So we've got one-to-one functions. Okay, everybody good with that? Boy, you must really trust me, because I could just be feeding you a big line right now. Okay, all right, let's take a look at these problems right here. So it says evaluate each expression, give the answer in degrees. So just in degrees, so that might be a little bit more comfortable. We want the cosine inverse of radical 3 over 2. So this is a ratio. The answer that comes out should be an angle, and we're going to quantify that a little bit more. If it's a cosine inverse, it's got to be an angle between 0 and 180 degrees. Now, I'm not going to write this down every time. We're going to do that on the first couple just to kind of emphasize the point. That's the ratio. We need to come up with an angle that's in these two quadrants right here between 0 and 180 degrees. So let's think for just a second. The unit circle can be really helpful. This should be a pretty familiar angle, pretty familiar ratio. Let's see. Cosine is the x-coordinate on the unit circle. It's a positive x-coordinate, so we've got to be over here. It's radical 3 over 2, and that's 1. You should recognize this is a 30, 60, 90. If we need to draw that in there, that's fine. If this is the short leg, this is the small angle, so this is 30 degrees. So what's the answer on this problem? 30 degrees, okay? That's the angle in standard position, okay? Okay, let's do this one. This is a ratio. The angle that we're going to get out is going to be an angle, and it's got to be between where and where? Negative 90 and 90, right? Quadrant 1 and quadrant 4. This is the y-coordinate on the unit circle. So do you have a triangle or an angle on the unit circle that's in quadrant 1 or quadrant 4 that has a y-coordinate of negative radical 2 over 2? Now, if you've got the unit circle memorized, you should have that straight. Well, you at least have one that's coterminal, so think in terms of that. And if all else fails, then you do this. I've got to draw a triangle in here. I need a negative y-coordinate, so that means I'm going to be down here. This is negative radical 2 over 2, and this is 1. That's got to be radical 2 over 2. What triangle have I drawn here? What type of triangle? 45, 45, 90. This is 45. Is that the answer to the problem? It's not, because we have to indicate an angle that's between negative 90 and 90. So if I had to say what this is, what's the answer? Negative 45 degrees. Okay, now, we've done 2 problems so far. Are there any questions? Yeah, Skylar. Because this is, if I draw this triangle and make it nice and big, if this is negative radical 2 over 2, and this is radical 2 over 2, and this is 1, again, you can find these using the Pythagorean Theorem. If you know this is negative radical 2 over 2, and you know this is 1, you can use the Pythagorean Theorem to find this. Or, if you've got those special right triangles memorized, like we did in, I think it was section 1.2, okay, if these two are the same, these two angles have to be the same. So if this one's 90, there's only 90 degrees left for the two of those. So if we take 90 and cut it in half, that's got to be a 45 degree angle. If that's a 45 degree angle, and we measure this going this way in a clockwise direction, that would be negative 45 degrees. Does that make sense? Sure? Okay, any other questions? Yeah?
Does it matter if you use the negative or positive, like instead of writing negative 45, you use 315?
It does. What would be wrong if we wrote 315 degrees as the answer to this problem? Okay, it's not in the right range, if you want to think of it that way. It says we have to have an angle in between negative 90 and 90. So 315 is coterminal with negative 45, but we take the negative 45 because it's in the range they specified. Excellent question. Anything else? If those are the only 2 questions, I'd be a little surprised, but I suppose that's good. You sure we're all right? Okay, let's take a look at the next one. Yeah?
So I have a question on A. So how do you know the cosine, like the...
Okay, so let's look at A really closely. This is the x-coordinate on the unit circle, so it's going to be the side running along the x-axis. So that's going to be radical 3 over 2.
But why can't it be the y? Like, because it's like 60 degrees.
Because it's, okay, well, let me show you, let me finish this explanation, and then I'll give you another way to do it. Okay, cosine is the x-coordinate. There's no getting around that. If you go back and look at the unit circle, so if I open this back up, here are the answers. If I go down here and I take a look at this guy right here, remember, we wrote this down at the bottom. The x-coordinate is the cosine of the angle, and the y-coordinate is the sine of the angle. Okay? So that's the quick way to do this, to know that this has to be the x-coordinate, so it's got to go here. We know it's the unit circle, so that's got to be 1. So either from memorization or by the Pythagorean Theorem, you can find that this is 1/2. If this is 1/2, that's the short leg. That makes this the long leg. So this one's 60, that one's 30. We're talking about the angle in standard position, so that's this one right here. Is that okay? Yeah. If that's not good enough, then how could you think of this? That other technique that I did above? This is the adjacent, and this is the hypotenuse. So let's draw a picture that is, again, with cosine inverse, it's got to be in quadrant 1 or quadrant 2. The adjacent is positive, so this would be radical 3, this would be 2. Again, using the Pythagorean theorem, you could find that this is 1. And once you have these, you just flat have to be able to recognize, my gosh, I've seen that pattern before. That pattern where the long leg, or the other side, is radical 3 times the short one, and where if I take the short one and times it by 2, I get the hypotenuse. That's the pattern for a 30, 60, 90. Does that work? Anything else? Chapter 1's important. Okay, so let's take a look at this one right here. Now, if it's tangent inverse, that means this is a ratio of sides. Now, the problem with tangents is that we don't memorize those on the unit circle. So that's why it's good to fall back on the fact that, hey, I know this is a ratio. I can put it over 1. I'm looking for an angle. And what's the range for tangent inverse? Which quadrants would we be in? I'd be in quadrant 1 or 4. So let's draw what this looks like, and let's think of this in terms of, now I did adjacent and hypotenuse before. I'm going to think of this in terms of, this would be the y-coordinate over the x-coordinate. If you want to think opposite here and adjacent here, that's totally fine with me. So let's draw a triangle. If the opposite side is going to be negative, do I go up or down? I go down. So I'm going to draw a triangle like this. The opposite side is negative radical 3. The adjacent side is 1. What's this got to be? 2. It's got to be 2. Again, it's that pattern for a 30, 60, 90. Long or short leg right here? Long leg. Is that the big angle or the small angle? That's the big one, so it's got to be 60 degrees. So if I measured from standard position and I went clockwise, what's my answer to this problem? Answer to this problem is, because I went clockwise, it's going to be negative, and how big is that little angle right there? 60 degrees. Okay? Any questions? Sure? Okay, let's look at this one right here. Which coordinate? Y-coordinate. Which quadrant? It's got to be 1 or 4, and because it's the y-coordinate and it's positive, it's got to be quadrant 1. Radical 3 over 2. 1, 1/2. Again, you don't have to write all this, but I mean, it should be pretty easy to think your way through these. What's the answer? Answer 60 degrees, okay? Because that's across from the long leg. Measure from standard position going up, it's going to be positive 60 degree angle. So there's our answer on that one. Any questions? Do that one. Check with your neighbor. There's our ratio, or our x-coordinate. We're looking for an angle between 0 and 180 degrees. We're thinking over here, negative radical 2 over 2. If you want to fill in the rest, be my guest, but this is really the only important piece, because we know that's 1 and we know that's radical 2 over 2. Again, we went back, it's negative. We went up, the y-coordinate would be positive. The minute the two of these are the same, how big is this little angle right here? 45 degrees. Now, the answer is not 45 degrees because we have to measure it from standard position. We've got to measure from here going that way. So what's our answer? 135. See why that unit circle is so important to have that memorized? Okay, any questions? That's a ratio. So make it look like one. That's the opposite, that's the adjacent. They're both positive. What's this angle right here? 45. That's the answer on that one. Okay, are there any questions? Sure? Okay, if we're working with a common angle or we're working with the unit circle, this stuff has to be second nature. So up until 1.4, it was all memorizing the unit circle kind of in the forward direction. Now we're using the information on the unit circle in the opposite direction. You can be given a ratio and you have to tell what the angle is. Instead of being given the angle and you tell them what the trig ratio is. Okay? You've got to know that unit circle inside out and backwards. Okay? From angle to ratio and from ratio to angle. Okay? Now, you've got some problems on your assignment, like for number 10. If it's not a common angle or it's a tangent inverse, it's more difficult because those things don't appear on the unit circle. Okay? So let's take a look at this one right here. It says sine inverse of 2/5. This right here, again, is a ratio. It's certainly not a ratio I recognize, but we could at least do this. We could say, well, let's see. It's got to be in one of these quadrants. And remember, this is the opposite and this is the hypotenuse. So it would have to look something like this. This is going to be 5 and this is going to be 2. Now, is the other side 3? Please say no. Very good, you got the answer right. The answer is no. We could figure out what the other side is using the Pythagorean Theorem. 5 squared should equal 2 squared plus x squared. That's 25. That's 4. Move that over. This is going to be the square root of 21. It's not 3. It's the square root of 21. It's pretty big. Now, if we were actually going to figure out what angle this is, what do you have to use to figure out the angle? Is it an angle you recognize? Nope. Shouldn't be. I'd think you were a complete math nerd if you knew what angle that corresponded to. You've got to use a calculator to figure this out. But remember, we said last week, if you're going to use a calculator, you ought to know roughly what to expect from your calculator. Am I expecting an angle that's bigger than 45 or less than 45? Probably less than 45, because this is 2 and that's more than 4. Okay? So this is a long side here, this is a small side here. That's going to be a fairly small angle, but we're definitely expecting this to be positive. So let's grab the calculator. And one thing you want to do is make sure you're in the right mode. So I'm going to turn this on. Check the mode. We're in degree mode, so I'm in great shape there. I'm going to clear everything off, and I literally, remember, the second function button often gives you the inverse of that, whatever that key was. So notice on log, the inverse is 10 to the x. On ln, its inverse is e to the x. Look at the square button. What's the inverse of squaring something? Taking a square root, and there it is right there. So we're going to type in second sine, so there's sine inverse, 2 divided by 5. We're expecting a positive angle, a little less than 45. Hit enter. We got we'll call it 23.6. There's our answer. It's literally that simple. You have to be able to do these because you know the unit circle well. You have a few problems where it just says, hey, use your calculator. Any questions? I don't recognize that. Let's type that into the calculator. But before we type it in, what are we going to do? We're going to know roughly what we're looking for. Tangent inverse. What is this right here? It's a ratio. Let's make it look like one. This is the opposite side over the adjacent side. So the opposite is 2.43 and the adjacent side is 1. Are we expecting a positive or a negative angle? Positive. Bigger than 45 or less than 45? Bigger than 45, because this one over here is the long one. In fact, I bet it's a lot bigger than 45. Let's double check and see. Tangent inverse. What do we have here? 2.43? 67.6. Okay? Any questions? Sure? Okay, flip the page over. Okay, on some of the problems it says find the exact value of sine alpha, cosine alpha. So basically all the trig functions for each of these angles right here. So if I'm working with alpha, okay, and this is where you can't really forget opposite, adjacent, hypotenuse, because you are going to use those occasionally. If I'm working with alpha, this would be the adjacent, this would be the opposite. I still need to find the hypotenuse. So the hypotenuse squared would equal the 7 squared plus the 3 squared, so that's going to be 49 plus 9, so that's going to be 58. H squared would equal 58. That means H is the square root of 58. Now, 58 is not my favorite number, but can somebody tell me something nice about 58 when it's underneath the radical? How about you say it doesn't simplify? It doesn't simplify. You are correct. Okay? So the nice thing about this is it doesn't simplify. So if I'm going to go through here and write down the sine of alpha, the cosine of alpha, and the tangent of alpha, all I have to do is say, you know what? Let's see. Sine is the opposite over the hypotenuse. 7 over radical 58. Cosine is the adjacent over the hypotenuse. 3 over radical 58. Tangent is the opposite over the adjacent, so that's going to be 7 over 3, and I am done right there. Good? Now, they did ask us to figure out what the sine of beta, cosine of beta, and tangent of beta were, but this isn't going to be too difficult because I already figured out what the hypotenuse is. The only thing I'm doing now is renaming things according to this angle. This is now the opposite, and this is the adjacent. Now, we should notice some patterns here. What about the sine of beta? 3 over radical 58. It's the same as the cosine of alpha. Cosine of beta? 7 over radical 58. And tangent of beta is just going to be 3 over 7. And I'm done with that problem right there. All 6 of them pretty easy to find. Any questions there? Yeah?
Do you not have to? Oh, no.
Good? Were you going to say like reduce or simplify or something? Okay. All right. So next example. Occasionally you're going to be given instructions that say solve the triangle. If they say solve the triangle, it just means this. Find all the angles and all the degrees. So we've got a right triangle. That's good because they just gave us an angle, where the legs are 6 and 8. So let's draw a right triangle. Let's put a leg of 8 and a leg of 6. Does anybody recognize this? It's a 3, 4, 5 triangle. It's a Pythagorean triple. Each one of these is twice as big as they used to be. So this is 2 times 3. This is 2 times 4. This should be 2 times 5. So that's going to be 10. If you don't believe me, use the Pythagorean Theorem. Figure out what it is. It'll be 10. Now, I have all the sides. I've got all the sides. Okay. Other side is 10. Got that one right there. So there's 1, 2, 3 sides. I've got one angle. One of the angles is 90 degrees because they said it was a right triangle. I need to find this one, and I need to find this one. Okay, so I've labeled alpha and beta. Here's what I'm going to do. Well, let's see. Why don't you figure out what you're going to do to figure out, let's say you have to figure out alpha. Write down what you'd do to figure out alpha. Check that with what your neighbor would do. See if they were the same, or at least see if they produced the same answer. So here's what I would do. You don't have to do this, but here's what I would do. Since they gave me 8 and 6 in the problem, I know for a fact I didn't make any mistakes with the 6 and 8 because all I did is copy them down. I could have screwed up the 10. I didn't, but I could have. Okay? I'm going to use these two because they gave them to me, and I'm going to name them with respect to alpha. So if this is alpha, that's the opposite side, and this is the adjacent side. What trig function relates the opposite and the adjacent side? Tangent. So I'm going to say the tangent of alpha should be 6 over 8. Or what I do in effect is I say this, you know, I'm not interested in that equation. What I want is I want alpha all by itself. So I take the tangent inverse of this side and the tangent inverse of this side. What does tangent inverse do to tangent? Okay, not really cancel out. What it does is it undoes it. Whatever this one did, that one undoes. So I get alpha equals tangent inverse 6 over 8. And that's not one that I recognize, so I grab the calculator, I type that in. So I'm just going to, recall tangent, and I'm going to type in 6 divided by 8. Am I expecting a big or a small angle? This one is smaller than that one, so this should be it should be smaller than 45. So I'll hit enter. Whoops, what did I do wrong? Oh, there we go. 36 we'll call it 36.9. Okay, so alpha is 36.9 degrees. Now, I have all three sides. I have two angles. Do I need to use trig to find out what beta is? No, just subtract from 90, and that's going to give us, correct me if I'm wrong, but that's going to be 53.1? 53.1 degrees. So I've solved the triangle because I have all three sides, 6, 8, and 10, and all three angles, 90, 36.9, and 53.1. Good? Okay, this next one hopefully is pretty easy. This is good news because on this one, they told us that alpha is 50 degrees. We already know this one's 90, so you can actually fill in the other one. What's the missing angle? 40 degrees. Got them all there. And it says side A. Now, hang on just a second. This is alpha, and this is side A. 1, 2, 3. 1, 2, or 3. Where do I put the 10? 3, because it's across from angle alpha. Okay, see how they match? That's an A, that's an A. So this is side alpha or side A, if you want to think of it that way. So the only thing I need to find are the hypotenuse and the adjacent side. Okay, so I'm going to work with the 50-degree angle. So this is the opposite side, this is the adjacent side, and this is the hypotenuse. Let's find the adjacent first. Again, what trig function relates the opposite with the adjacent? Tangent. So the tangent of that 50-degree angle should be the opposite, which is 10, over the adjacent, which is, let's call it x. Okay? Can you solve this? That's ugly, but it's just a number. So let's multiply both sides by x. So that's going to give you x tangent 50 degrees. If you can speed this up, be my guest. And that's ugly, but again, it's just a number, so I'm going to divide by tangent of 50 degrees. And that now is something that I can plug into my calculator. So that x is 10 divided by tangent of 50. And I'm sure somebody has that typed in by now. What'd you get? 8.39. Can somebody confirm that? 8.39. Let's stop and think for just a second. Everybody watch, please. Is 8.39 a reasonable answer for this? And if so, can somebody tell us why? It should be shorter than this one right here because that's across from a 50. This is across from a 40-degree angle, so it ought to be a little shorter. So that looks pretty darn reasonable. At this point, you could use the Pythagorean Theorem if you wanted to, but it would be much better if we started with that side that they gave us. We know there's no error there. This angle, and try and find what the hypotenuse is. So if we call the hypotenuse, oops, let's call it something different. Let's call it h. What trig function relates the opposite and the hypotenuse? Sine. So, oops. The sine of 50 degrees should be equal to the opposite over the hypotenuse, which is h. Did you notice anything about these guys last time when we solved one like this? They just switched places. So h is equal to 10 divided by the sine of 50 degrees. Type that into your calculator. It'll spit out an answer. That answer had better be bigger than 10. Probably quite a bit bigger than 10. What is it? 13.1. Okay? So I've got all the angles. That's 8.39. And now I have all the sides. That's 13.1. Okay, any questions? Sure? Okay. I've got two story problems I'd like to look at. We've got about 6 minutes to do that. We're not going to finish the example in the book, but we will be able to get started. These are classic trig problems. If you've got a parent or an older sibling who's taken trig, you could show them these two problems. They'd say, oh, I've seen those before. Don't remember how to do them, but I've seen them before. Okay? So we need to talk about some terminology here. So normally when we measure things, we usually measure them from horizontal. And the same's true if we're out surveying the world, we usually measure things from horizontal. So if we're looking up to the top of the Empire State Building, as we look up, we call that an angle of elevation. Okay, because we're elevating our head, we're looking up. Okay, if we were at the top of the building and we were looking down, again we're going to measure from horizontal, but when we look down, we measure that as an angle of depression. So we elevate our head, angle of elevation. We kind of depress our head because we're looking down. That's called an angle of depression. Okay, so you need to know those in order to solve some of the problems that you're going to come across. So here's example 5. It says a guy wire. A guy wire is just a support or a guide wire, okay? Connects the top of a radio broadcast tower with the ground. The wire is 300 feet long and makes an angle of 48.9 degrees with the level ground. How tall is the tower? So here's what we've got. Level ground, or reasonably level. There's our radio tower. Hopefully that's sticking straight up out of the ground. Remember, we're only working on right triangle trigonometry at this point. Okay? And then it says the wire makes an angle of 48.9 degrees with the ground. And what it wants to know is, how tall is this? Now, do I have an accurate picture? Mike, not yet. What do I need?
The distance from the pole to the wire.
Yeah, it's okay. We do need this, perhaps. The wire's 300 feet long. Where's the wire? This guy right here. It's the hypotenuse. Okay, and you even naturally, once we get this picture on here, you stop calling it a wire. You called it the hypotenuse. Okay. Now we don't really need this side right here, although we could find it if needed. The only thing they want us to do is just find this right here. So I'm going to call this y, and then I'm going to think for a second. If I'm working with this angle, I could figure out everything on this triangle, but I don't need to. I'm just going to say I'm working with this angle, so that makes this the opposite. That makes this a hypotenuse. What trig function relates the two of those? So the sine of 48.9 degrees equals the opposite side, which we don't know, over the hypotenuse, which is 300. And what's cool about this equation as opposed to the other one? All you have to do is times both sides by 300. It cancels over there, and we get y equals 300 times the sine of 48.9 degrees. We type that in the calculator, and we end up with y equals, surely somebody has this done by now, what? 226.1, and I'd label this, so what would it be? Feet. Okay, now, is that a reasonable answer? Absolutely. It's got to be less than 300. Okay? All right. Any questions there? Okay, that is enough to do every problem on the assignment, except you're going to have a couple problems like this. And these are a little bit hairy. This is actually an example out of the textbook. I'm going to make this a little bit smaller so you can see where we've got room to work and see our diagram. So, this is in the textbook. If you want to write this down, I'm not sure if I solved this the same way the textbook does, but we end up in the same place. So, we're going to do it my way. How's that? So it says the angle of elevation of the top of a water tower from a point A on the ground is 19.9 degrees. So, here's our water tower. They've drawn us a picture. Here's the 19.9 degree angle of elevation from point A. From point B, 50 feet closer to the tower, so they've indicated that we're getting closer to the tower, the angle of elevation is 21.8. So, if you were looking at a tall building, and you looked like this, and then you moved closer, the closer you get, the more you have to crank your head up. So it makes sense that the angle of elevation has increased. It's gone from 19.9 to 21.8. Good there? Okay. It says, what is the height of the tower? How tall is this? So this is what we're really after. We're after y. That's what we want to know. Questions? Okay. The problem with this is you can't solve for y directly. You can't just set up a little trig equation and say, oh, this is going to spit out the answer for y. Okay? You actually have to do this. You have to think of this in terms of two separate triangles. A big one that looks like this, where this is 19.9. This is y. And how would I label this? X plus 50. Okay? And then we're going to do another one that looks like this, where this is 21.8. This is y, and what is this? That's just going to be plain old x. Okay, now, does everybody agree that I've got two triangles that represent this little drawing here? Good? Okay, I'm going to cover this up. And we're just going to look at this. So again, this is a right angle, and this is a right angle. So I can use right triangle trigonometry. Okay, and that's a 9, remember? This is the opposite, and this is the adjacent. Is there a trig function that relates the two of those? There is. So I'm going to write that the tangent of 19.9 degrees is equal to what? Y. Over x plus 50. Is that all right? Any questions there? Okay, let's turn our attention to this guy right here. That's 21.8. This is across from it, so that's the opposite. This is the adjacent. So what trig function relates the two of those? Tangent. The tangent of 21.8 degrees is equal to y over x. Now, does everybody agree that I've come up with two equations involving trigonometry that represent those two triangles? Okay, then I'm going to slide this down, and all we're going to do is stare at that for just a second. That's a number. And that's a number. So really what you have here is the equivalent of, if I wrote, now this isn't it, don't write this down. Let's say I had 7 equals y over x plus 50, and I had 9 equals y over x. How would you solve that? Substitution, right? You'd probably do that using substitution. So you'd solve one of these for x or y. Probably y would be the easiest, okay? And then you'd plug it in, and you'd solve for the x, and then you'd plug back in and solve for y. Now, on this particular problem, what variable are we trying to get? We're trying to figure out what y is. So which one do you think we ought to substitute for? You could substitute for x. So if we were to solve this one for x, this would be x equals y over tangent of 21.8. And where can I put that? I can put that over here, right? And then I'd have an equation with how many variables in it? Only one. Only one variable. Now, would it be a nasty equation? You bet it would be. Any fun to solve? If I paid you $50, maybe it'd be fun. Okay? That's not going to happen, by the way. Okay? All right, so what I'd like you to do is, that's the setup for this problem. Okay? There are several ways you can finish it. You could solve for x or solve for y. Sometimes it might be easier to solve for the x and then indirectly substitute and solve for the y. You can do that. Take a look at the textbook. This is problem or example number 8 in the textbook. That's it for today. We'll finish the chapter up on Friday. Remember, we've got office hours tomorrow, so I'd like to come back and discuss this. Any questions you have from 1.5, remember, we'll correct 1.4 on Friday. Really would be a good idea if you came done with 1.5 on Friday also. Okay, but have a great day.